Madhya, am I audible? Okay. So in the previous class, we covered this formation of monohydrate, right? Now we are going to start a new chemical reaction. This chapter will be completed. After this, we are going to do coordination. So see, this is the next chemical properties, which is esterification, that we have already studied in alcohols. We have already studied, and in this chapter also. So esterification, basically, we are going to see the chemical reaction of carboxylic acid. We know that when carboxylic acid and alcohol react in the presence of acid, then we will get ester. That is called esterification. So this is your carboxylic acid, and this is your alcohol. This is an alcohol hard as OH. Then what you will get? The reaction is reversible reaction, first of all, in the presence of H plus. In the presence of H plus. So, please wait a minute. Sorry. Then you will get RC OOR dash, and H2O will be eliminated. To understand this reaction, you can either write like this. This is your carboxylic acid, and this is your R dash OH. And you are going to take, you are going to carry the reaction in the presence of H plus. So what you need to do, just remove this OH, OH with H, then you will get H2O, and you can see on the left hand side it says RCOO and then R. This is your ester. So the process is known as esterification. Okay. I think it's clear to all of you, both of you. Then now let me know when you are done with this.
Yes, we're done.
Very good. Now the next chemical reaction is the reaction with, the third is reaction with PCl5, PCl3 and SOCl. Now you can see this is your carboxylic acid. If it is going to react with PCl5, this OH will be replaced by one of the chlorine, so you will get basically acyl chloride along with POCl3 and then HCl. If you are going to react this with PCl3, then you have to take 3 moles of carboxylic acid, and then you will get 3 moles of this RCOCl along with phosphoric acid, that is H3PO3. And if you are going to react this RC double OH with SOCl2, again you will get acyl chloride or acyl halide, that is RCOCl plus SO2 plus HCl. If you remember, the first chapter in which we reacted alcohol with PCl5, PCl3, and SOCl2, and we get same byproduct in that also. Only the difference is that there was alcohol, then we will get alkyl halide. There was alcohol, then we will get alkyl halide. There was alcohol, then we will get alkyl halide. But here you can see, since we have carboxylic acid, then we will get carbo, then we will get acyl chloride. Is that clear? Please do write it. Let me know when you're done with this. Are you done with this?
Yes, sir, done.
See, we are going to react this way. Carboxylic acid reaction with ammonia. The fourth one is reacts with ammonia. Now, as you can see, if you have carboxylic acid, that is CH3COOH, and you are going to react this with ammonia, that is NH3. You know that this is carboxylic acid. That means it will lose its hydrogen in the form of H plus. And since we know that if it loses H plus, oxygen will have negative charge, and there is lone pair on ammonia. So it will attack on this and it will form NH4 positive. Now you can see this is ammonia and cation, it is ammonium, NH4 positive, and this is negative. So they both combine together CH3COO minus NH4 positive, and the bond between this will be ionic bond because it will be because of the force of attraction between negative and positive charge. Is that clear? And this is known as ammonium acetate. If you don't get it, let me know. I will again explain. First, what happens? It loses H plus, so there is negative charge on oxygen, and this H plus will be attacked by this NH3 ammonia, and it will form NH4 positive, and there is a force of attraction between NH4 positive and CH3COO negative. So it will form ammonium acetate. After this, you are going to heat it, and then H2O will be eliminated, and H2O will be eliminated. Now, as you can see, what will form here, basically, amide will form. How? See, two hydrogen from here and one oxygen from here will be eliminated. So what we will get? We will get CH3CO NH2, and as you can see, There is two hydrogen that is eliminated with one of the oxygen, so it will form H. H2O will be eliminated. So here we will get amide. What it is? It is amide, and its name is common name is acetamide. Is that clear? Please do let me know when you are done with this. Are you done with this, Ayman? Thank you, Nadia.
Yes, sir.
Okay, so what we just did, when carboxylic acid is going to react with ammonia, you will get ammonium acetate in this case, and after heating it, you are going to remove H2O, then it will be converted into amide. So if I'm going to give you this reactant, which is a carboxylic acid, and you can call it benzoic acid, and you are going to react it with NH3, then you will get a product. Let me know the structure of the product, and after this you are going to heat it, then H2O will be eliminated. Can you do this? I think you can do this. Do let me know when you are done with this. Aman, are you done with this?
Yes, sir. Done.
Very good. So as you can see that this carboxylic acid will be converted into this C double O negative and NH4 positive. And after heating it, you can see you will get CONH2. double bond ONH2, you can write either like this, and H2 is eliminated. So this is the product that you will get. Very good. Ammonium benzoate. B is benzamide. Okay. Very good. So Aman, did you get the same product?
Yes, sir.
So I'm going to change the slide. And if I'm going to give you, it's a very important reaction from the CRT. So basically, if you are having dibenzoic acid, C double bond, and you are going to react it with NH3. So as you know, this react here is in excess. So it will react with both the carboxylic acid. So what you will get, you get C double O negative NH4 positive. In the same way, acid will also be converted into same C double bond O negative NH4 positive. After this, if you're going to heat it, if you're going to heat it, H2O will be eliminated. But here, two H2O will be eliminated. We will have two group of this, and in this way, you will get CONH2 here as well as CONH2 here. And the name of compound is very important. That is phthalimide. That is not, it's not phthalimide, it's phthalimide. Phthalimide. And if you're going to heat it strongly heating, if you're going to strong heating, then the removal of NH3 will take place, and in this way you will get phthalimide. You will get phthalimide, and phthalimide is basically what you can see. Phthalimide. This is benzene, and here C double bond O, and here as well C double bond O, and you can see there is two NH2, NH2. So NH3 will be removed, and in this way, this is your phthalimide. And this is your element. Please do it. Is my video lagging?
Yes, sir.
Please do respond. Okay, I just switched off my video because it's lagging, disturbing. Are you done with this? Are you done with
Yes, sir.
Simon and Maria? Okay. Now the next chemical properties, that is reactions involving COOH group. And here the first one is redox. So as you know that carboxylic acid, if you are using a mild reducing agent, it will be converted into aldehyde. And if you are using a strong reducing agent, then you will be getting directly a primary alcohol. So if you have carboxylic acid, and if you are going to use a very strong reducing agent and it's very expensive, that is lithium aluminum hydride in the presence of ether, followed by hydrolysis, that is H2O, then you will be getting directly RCH2OH, RCH2OH, a primary alcohol, primary primary alcohol. This is what you will get. Also, at the place of LiLH4, you can also use diborane, that is B2H6. Is that clear?
Yes, sir.
So if I'm going to give you carboxylic acid like this CH3, CH2, COOH, and using any of these reagents like lithium aluminum hydride in the presence of ether or B2H6 diborane, followed by hydrolysis, then please let me know the IUPAC of the product. Please do let me know the name of the product. Maria and Ayman. Very good. It will be directly converted. You can see this is your propanoic acid. Propanoic acid. Then it will be directly converted into propanol. Propanol, and its structure will be CH3, CH2, CH2OH. Is that clear, both of you? Can we move to the next reaction? Very. Now next is decarboxylation, and you have studied in the previous class, that means class 11, and also in this chapter. So see what is decarboxylation. We will use basically soda lime, which is mixture of NaOH and CO. So basically, we are going to study about decarboxylation. So what is decarboxylation? If you have salt of carboxylic acid, and if you're going to react this with soda lime. Soda lime is basically mixture of NaOH and CO calcium oxide in 3:1 ratio. 3:1 ratio. This is what soda lime mixed in this. Then you are going to heat it. Then you will get directly RH, and it will be the byproduct will be sodium carbonate, that is Na2CO. That is Na2CO3. So what just happened? Basically, if you have carboxylic acid like RCOONA, you can see this whole product will be eliminated, and H will be associated go with this, so it will be converted into hydrocarbon, and this Na2CO3 will be converted NaCOO will be converted into sodium carbon. So whatever is the number of carbon here, the hydrocarbon formed will always be one lesser than this. If you have a carboxylic salt of 4 carbon, here the hydrocarbon will be formed of 3 carbon, because one of the carbon will be here. Is that clear? Please do let me know when you are done with this. Are you done with this, Ayman?
Yes, I finished.
Now see, the next reaction, which is very important, and also your name reaction, that is first write the topic of this reaction. Substitution reactions in hydrocarbon part. In hydrocarbon part. So basically, we are studying every chemical reaction that is possible with carboxylic acid. So here, if you have RCOOH, so the substitution in this part we are going to study. In this, I'm going to write the first reaction, that is halogenation, and this reaction is a name reaction. That is basically your sorry, Helmholtz-Zielinski reaction. So I'm going to write a point about this. Just write with me. If you have a carboxylic acids, the carboxylic acids having an alpha hydrogen, having an alpha hydrogen, are halogenated at alpha position, position on treatment with either chlorine or bromine, the reaction is very easy. Either chlorine or bromine in the presence of a small amount of red red phosphorus to give alpha halocarboxylic acid. Alpha halocarboxylic acid. And here the reaction is known as Hell-Wolfhard Jalinski reaction. So first write it and then I will explain the reaction. I think you know how to see or how to recognize which one is alpha and which one is beta, right? Do let me know when you are done with this, please. Are you done with this, Aman, Madia?
Yes, sir.
Okay. Now see what does this statement say. It's very first of all it should have an alpha carbon which must have alpha hydrogen. So if you are having a carboxylic acid like this, so you know that this is alpha carbon and it has two alpha hydrogens. That is enough. At least one alpha hydrogen should be there. So you are going to react this chlorine or bromine in the presence of red phosphorus, red for phosphorus, and followed by hydrolysis. So what will happen? One of the hydrogen will substitute by this X. So it will RCHX and leave it as it is OH. And X now the name will be alpha halo. The name will be alpha halo carboxylic acid. So you just need to search for alpha carbon and then go for alpha hydrogen. Just to replace alpha hydrogen with X. That means chlorine or bromine. You will get the product. So I'm going to write the reaction. Please do it. Pr2 in the presence of red phosphorus followed by hydrolysis. Please do let me know when you are done with this. Are you done with this? Very good, Nadia. Aman, what about you? You just need to pick up the alpha carbon. This
Sir,
is
it's
your
butonic acid.
carboxylic acid. Butonic acid? Basically, did you say butonic acid? So one of the hydrogen will be replaced by bromine and then it will be C double O. If you want to write its common name, it will be alpha bromo carboxylic acid. And if you want to write its IUPAC name, it will be basically 1, 2, 3, 4. Its name will be 2-bromo-butanoic acid. 2-bromo-butanoic acid. Please do let me know if you still have any doubt in this.
No, sir, I
Ayman
got
and
it.
Madhya, you have got. Okay. Can I change the slide, Ayman?
Yes, sir.
Now, before starting the next reaction, the last reaction of this chapter, that is ring substitution. That is ring substitution. I want you to write the resonating structure of this carboxylic acid. Can you do this? I think you can do this. Please do it. And if you are unable to do it, please let me know. Are you done with this? Please do let me know when you are done with this.
Yes, sir. I need help.
Okay. See, there are two types of resonance, right, Aman? There are two
Yes.
types of resonance. One is plus R and one is minus R. So this carboxylic acid comes under minus R. Means it will withdraw electron from the ring. So it will take electron from here to here. So what you will get, wait a minute, let me just stop the share because it's, okay. Can you see the screen?
No, sir.
Please do let me know when you are able to see this.
Yes, sir. I can.
So it will be, as you can see, since carbon is giving its electron, it will be like this. C positive and OH, and the O here will be negative. Yes or no? Please do let me know. This will be the scenario. Ayman,
Yes, sir.
and after this, you are going to move this bond to here, and then you will see that the positive charge will be here now, and there will be double, and it is positive at it is as it is, and there is OH and there is O negative. And again, if you are going to move this, then there will be double bond, and positive charge is here now, and there is no positive charge at this is by mistake. And now you can see it is OH and this is O negative. And again, if you are going to move this to here, then there will be positive charge at ortho with respect to C. This is positive, double bond, and this is double bond C, OH, and then O negative. And then this moves to this and this to this. So what you will get, it's very easy. That is, this is your double bond, double bond, double bond, and you can see this is the delocalization of pi. Yes or no?
Yes,
Ayman.
sir.
So please do write it and let me know so that I will start the next reaction, that is ring
Okay, sir.
substitution. Aman, are you done with this?
Almost.
Okay.
Done, sir.
Very good. Now see, Aman, ring substitution reaction. This is your benzoic acid. And if you're going to react this benzoic acid with concentrated HNO3 plus concentrated H2SO4, then what you will get? There will be generation of NO2 plus, which is a electrophile. And as you can see, electrophile, that means electron deficient compound. At what place it will be attacking? As you can see, there is positive charge. That means it is already having electron deficiency at ortho, then para, and then para, and then again at ortho. So only two places that NO2 plus can attack is meta and meta. Yes or no? Because if it is having electron deficient compound molecule, then it will be attacked where electron rich site is possible, or where there is electron rich site. As you can see, if it will attack an ortho, it is positive. It is already having electron deficiency. It is positive. It is also positive. So here the product form will be at meta. So COOH is basically ring deactivating or meta directing group. This type of group is known as meta directing group. Is that clear?
Okay, sir.
So its name is M-nitrobenzoic acid. M-nitrobenzoic acid. Another reaction of this we can write is, this is your carboxylic acid, again, which is a ring deactivating and meta directing group, and you are going to react this with Br2 in the presence of FeBr3, which will generate Br positive, an electrophile, and it will be also attacking at this place, at meta again. So please do write it and let me know. Let me know when you are done with this.
Yes, sir. Done.
Very good. I'm going to give you 3 questions regarding this acidic character. Then we'll start the new chapter. Please do write the
Okay.
question. Which acid of each pair shown here would you expect to be strong? CH3CO2H or CH3F? Oh, wait a minute. CH2F CO2H. And this two, which one is stronger acid? Then it comes CH2F CO2H or CH2Cl CO2H. Then the third one, CH2F, then CH2, then CH2, then CO2H, or CH3, CHF, CH2, CO2H. Then the fourth in fourth, F3C. And this is your benzene, and this is your C double OH. Or CH3, C double OH. Please just do this for, and then we'll move.
So we need to do this by seeing how the proton release, right?
Yeah, proton release, or you can see acidic character
Yes, sir. Okay.
is directly proportional to minus I or minus I, right?
Yes.
Or inversely proportional to plus I or inversely proportional to plus. Or which conjugate acid is more stable. So I think you can do it, and if you don't, just let me know. I will explain. Are you done with this, Ayman?
No, sir, I'm doing it.
No. Ayman, are you there?
Yes, sir, I'm done. I did all except the fourth one.
Okay, see. Which one is more acidic, first or second?
Is there a second?
Which one is more acidic for the second, first or second?
You said the same thing. The first one, CH2.
CH2,
Yes, sir.
CH2. CH2F or CH2Cl?
Yeah, CH2F.
What about the third one?
Yeah, CH2F.
No, there is no. This one, are you saying the first one?
Yes, sir.
No, this is more acidic because fluorine is quite far away from C. You can see this is the situation in the first case. And in the second case, you can see this is the situation. Yes or no? So you can see this is uh, nearer to COOH. So if it will go, the negative charge will be here and it can easily attract as compared to this. Yes or no? Inductive effect is distance dependent. So this one is more acidic than this. Is that clear? Hyman?
Yes, sir. I got it.
Okay. This, do you have any doubt in this third one? Yes or no? I'm not there.
Yes, sir.
Okay, now come to this point, which is very easy. This one is more acidic than this because there is 3 fluorine, which is highly electronegative and acidic character directly proportional to -I. That's why it is more acidic. And there is CH3, which has the side effect. It decreases acidity. Okay.
Okay, sir.
So can we start a new chapter, just the introduction?
Okay.
Are you comfortable? So basically, we need to go for this coordination. Let me write the name of the chapter.
So you're not sharing the screen.
Yeah, I just switched it off. Now you can see the screen, I think. Can you see the screen? Can you see the screen?
Yes, sir, I can.
So see, what is coordination compound? Before this, we have a term that is addition compound. What is addition compound? Addition compound is basically when two or more stable salts combine together, they form addition compound. And this addition compound is of two types. A double salt, the first one is double salt, and another is coordination compound. So what is the difference between this double salt and coordination compound? Double salt is the one which loses its identity in solution or soluble state. When you are going to dip a double salt in water, it will be totally dissociated into ions. But when it comes to coordination compound or complex compound, it do not loses its identity or its character in solution as well, or even in solution. So first of all, I am going to write the definition of coordination compound and then we will move. So see, compounds formed due to combination or more stable salt, more stable salt, which retain their identity. In solid as well as in dissolved state are called coordination. Is that clear? So again, I'm going to write here addition compound, and this addition compound is basically of two types. The first one is your double salt, and the second one is either you can write complex or coordination. Is to write it and then let me. Please do let me know when you are done with this.
Yes, sir. Done.
Very good. Now, what is this double salt? I am going to define it. So basically, it loses its identity in solvent or soluble state. So you can write with me those which lose their identity in solids. Those which lose their identity in solution. And here, first of all, we are going to clear this. As for example, more salt, we can say this is your double salt. More salt. So its formula is basically NH4 whole twice Fe SO4 whole twice dot 6H2. And if you are going to dissolve it, it will be converted into 2NH4 positive. All this will be converted into ions. Fe plus 2 plus SO4 minus 2 plus 6H2. It will lose its identity. When it is in solid state, it will be something else. But when you are going to dissolve it in water, it will be completely loses into its ions, and its ions will have different properties according to their ions. But when it comes to the complex or coordination, so we can write those which do not lose their identity even in solution. That is called complex or coordination. As for example, if you have K4FeCl whole 6, so it will be ionized. Only the outside bracket, whatever present, will be ionized. But inside bracket, there will be no effect. It won't be dissociated, and this is why it retains its property. The property will be only because of its this component, not this outside components. So it does not dissociate. That's why it retains its identity. Is that clear? Please do write. Are you done with this?
Yes, sir, done.
So, I mean, this is the concept behind it, and then comes some basic terms. So, from here, we are going to cover it on Wednesday. Will you be available on Friday? Or there is mock test? Is there mock test on coming Friday? Ayman,
Yes, sir.
is there mock test on Friday?
I don't know, sir.
I think
I'm not sure.
Okay. So,
But I can take an extra class. I'm free, sir.
okay, on Wednesday, we will decide.
Okay, sir.
So these are some basic terms that is related to this chapter that you are going to study and come in the next class, as well as go for nomenclature rule and writing formula as well. Then I'll see you in the next class. Just read about it, okay? Do you have any doubt?